Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of marine navigation and autopilot technology. This time we're discussing requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation. The challenge before the industry, General Cromwell, it seems to me, is how we navigate this push toward technological advancement without compromising the fundamental safety standards that have, governed maritime operations for such a long time. My position is that clarity, really above all else, is paramount. The foundational premise must be that requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation must be clearly defined in a step-by-step manner to meet three primary categories: audience needs, technical requirements, and safety regulations and restrictions for travel. These have to be prescriptive, unified, and frankly, non-negotiable.
I agree that clear definition is absolutely essential, Commodore Perry, but I do see a potential pitfall in overprescription. The shipping sector is moving incredibly fast towards greater autonomy. I mean, we're talking about remote operations, potentially even in complex coastal waters, maybe within the next decade. So if our specification documents are too rigid, too locked down, they risk becoming obsolete almost immediately. My contention is that we really need to frame the requirements more around performance and resilience, focusing less on, say, which specific piece of hardware is bolted to the bulkhead, and much more on how the human operator, the digital seafarer, if you will, interacts effectively and safely with the entire system. We need agility, yes, but built into the regulatory framework itself.
But agility can't come at the cost of guaranteed global standards. We absolutely need to explore this transition, the move from traditional paper charts to certified digital systems like ECDIS, and look at the really heavy demands of integrating sensors in real time, and crucially, how cyber vulnerabilities add a whole new layer of complexity to connectivity.
Exactly. And we must keep the focus squarely on the human factors as well, things like cognitive burden, which is a huge issue, the critical need for advanced, relevant training, and, importantly, the lessons we should be learning from recent, quite catastrophic failures where the technology, it was present, but the protocols, the human procedures governing its use were tragically inadequate. Okay, so let's ground this discussion where it has to start, the mandatory foundation. That's the Electronic Chart Display and Information System, ECDIS. It's been the required primary source for chart information since, 2011 now? And it's vector charts, the ENCs. They provide that baseline precision and consistency needed for accurate position fixing. But, ECDIS, it's really just the data backbone, isn't it? The real test of any specification is how it translates that raw data into a truly usable, effective operational environment on the bridge.
Precisely. And that operational environment, that's governed by the Integrated Bridge System, the IBS. Now, to ensure a high-quality experience for the user, the system specification must demand, essentially flawless integration of all the sensors and displays. And critically, this integration needs to adhere strictly to the standards laid out by the IMO, the ISC, and ISO. This is really where we define the user experience, and it brings us directly to that mandatory question. How can marine navigation and piloting systems for both inshore and offshore global navigation provide a high-quality experience for the user?
A high-quality experience. I think it really hinges on reducing the cognitive load on the watch officer. And that means we have to address the bridge working environment itself, the physical space. So specifications need to mandate specific qualities for the human-machine interface, the HMI. Things like minimizing the negative impacts of noise, vibration, poor lighting conditions. These are real factors. Classification notations like NAUTC, they exist for exactly this reason. A good specification demands intuitive design, consolidated HMI. Think of something like a multifunctional display, an MFD, that can act as radar, EXCS, and conning system all in one. Because let's be honest, if the user is constantly jumping between three separate screens, juggling different interfaces, then the specification has fundamentally failed, regardless of how good the underlying chart data might be.
I certainly agree on the principle of consolidation, General Cromwell, but you seem to be overlooking the necessary complexity that just naturally arises from a globally disparate fleet. We simply can't mandate a single unified hardware solution across the board because the operational reality is that the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation vary by region, size and type of vessel, and local laws and situations, weather, events, and tradition. That's just the world we operate in.
But surely that variation should mandate performance standards, adaptable standards, not rigid, prescriptive systems that might not fit every situation.
On the contrary, I believe that variation demands a baseline of standardized compliance. Take propulsion systems, for example. You mentioned flexibility. Look at the Shuttle-Yai hybrid feature. It gives designers fantastic flexibility in integrating diesel and electric power. But that flexibility exists within a defined regulatory box, particularly concerning things like emission control areas, the ECAs. So my point is, even when we allow for operational freedom, the core requirements, the safety features, the reporting functions, the interface standards themselves, they absolutely must remain uniformly specified to meet minimum global safety standards. And that applies whether we're talking about a small coastal tanker or, a massive offshore container ship. Prescriptiveness, in this context, guarantees that essential baseline of compliance.
Okay, let's shift gears to the technology requirements. This is where that tension between, let's say, prescriptive rules and the sheer pace of technological change really becomes apparent. The entire decision-making loop on a modern bridge relies on instantaneous, verifiable, real-time data flow. This is especially critical in, highly congested inshore waters or complex passages.
Absolutely. And the specification must demand that this data flow is continuous and truly comprehensive. I stand by the statement that the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation incorporates existing databases of charts, maps, noting passages, channels, obstacles, depths, traffic, weather, and updates maps and course in real time using satellite and real-time data from the bloat sensors of GPS, depth, speed, currents, fuel, and desired course and ETA. This list, this prescriptive element is vital, General. We need mandated minimums for accuracy for specific sensor inputs. Think about GPS, DGPS. The improvements since selective availability was turned off have been immense, and we rely on that accuracy. Depth data has to be robust. Systems like the Furuno FE700, for instance, are required to display and actually store a 15-minute history of the ocean profile beneath the keel. Speed logs, too, whether they're Doppler or electromagnetic, they must be integrated directly into the piloting tool.
That's fundamental for accurate ETA calculations and, crucially, for collision avoidance. These are absolutely non-negotiable inputs, and they need to be specified with precision. I see that list, Commodore Perry, but I also see it as a list of dependencies, and that reliance on instantaneous, accurate external data brings us immediately to the connectivity layer, which, let's face it, is increasingly dominated by high-speed, high-bandwidth satellite systems. Things like Starlink are changing the game. So this really begs the question, can we connect to both Starlink type of satellite systems and use library data to relay time, update new geographic region, and new weather data for marine navigation and piloting tool for both inshore and offshore global navigation? Is the spec ready for that kind of dynamic connection?
The answer has to be yes. We must. The industry is already adapting, leveraging multi-band solutions. Look at Marlink Sea-Link. They're integrating existing C-band capabilities with newer Ka and Ku-band VSAT services to provide that global access. And beyond that, you have specialized services like KNL, which are specifically addressing connectivity gaps in really challenging remote areas like the Arctic. And weather data, absolutely critical for both planning and execution, it must be seamlessly integrated. That means pulling data from regulatory sources like NavTex for maritime safety information, MSI, but also having the capacity to pull in global weather facsimiles. If we're going to mandate real-time course correction based on weather, well, then we absolutely have to mandate the connectivity needed to receive that weather data reliably.
Okay, I appreciate the push for seamless connectivity, Commodore Perry. I really do. But this is precisely where I think overly prescriptive requirements can actually become a weakness. Requiring continuous, high-speed connection dramatically increases the vessel's cyber attack surface. The growing risk of GPS spoofing isn't just theoretical anymore. It's an active, documented, strategic threat to positioning, navigation, and frankly, trade stability. So if the specification simply mandates high-bandwidth satellite connectivity without addressing the inherent vulnerabilities, it fails. It fails to demand the necessary cyber resilience. I would argue strongly that the specification must mandate systems designed with segregated critical navigation processors. Processors that can guarantee real-time data processing for essential functions like steering and positioning, even if the main network or the satellite communications link is compromised or spoofed. Resilience, not just connectivity, must be the specified requirement.
Recap and synthesis. So, if we try to synthesize our technical points here, it seems the ultimate navigation specification has to achieve data integrity above just simple compliance checklists. Yes, we rely on certified vector charts, the ENCs, referenced directly to WGS84. That's fundamental. But the key performance requirement is accuracy and availability. And that demands a specification focused on the system's capability, its ability to handle data fluctuations, potential errors, and external threats, not just, a list of required sensors ticked off on a form. And that focus on integrity, General Cromwell, must absolutely be paired with continuous regulatory evolution. We can't set it and forget it. I really must stress that the requirements specification for marine navigation and piloting tool for both inshore and offshore global navigation are updated and evaluated on an ongoing basis to incorporate needs and desires for new features and benefits and changes to existing regulations and requirements for marine travel. Think about the shift to new low-emission fuels, green ammonia, methanol, hydrogen. These introduce significantly higher onboard hazards, flammability, toxicity. The technical specifications have to evolve rapidly to keep pace, demanding new system safety envelopes. For instance, maybe requiring innovative water-driven pitch propellers that completely eliminate the risk of hydraulic oil leakage and contamination. That responds to both environmental pressures and safety pressures simultaneously. The spec has to be a living document.
Those technical upgrades are necessary, of course, but they often mask what I believe is the most critical potential failure point: the human element. The safety regulations category needs to learn directly from disaster. Look at the NTSB investigation into the tragic sinking of the SSL Faro. It exposed severe requirements gaps, deeply rooted in human factors. The failure of bridge resource management, BRM, effectively meant the crew's valid concerns about the hurricane, about the severe weather, were not adequately communicated or perhaps not adequately received by the captain. The specification itself must explicitly mandate protocols and training. These are procedural requirements to ensure the human element can effectively interact and sometimes even override or critique these highly automated systems we're implementing.
Well, that points back to a failure, perhaps, of existing regulations and their enforcement. Wouldn't you say, General Cromwell? The El Faro investigation specifically noted something quite important, that officers who obtained their credentials before 1998 often lacked mandatory advanced training in crucial areas like meteorology or ship handling in heavy weather. This created a potentially dangerous knowledge gap between, let's say, older operational experience and the sheer complexity of modern vessels and their systems. Therefore, the specification for adopting any new navigation technology must be absolutely prescriptive about the required advanced training, the ongoing certification needed to operate it safely and effectively. We have to ensure the operator is as highly specified in terms of competence as the equipment they're using.
Precisely. You cannot specify complex new hardware without simultaneously demanding new, sophisticated human factors requirements. Technology only enhances safety if the crew is properly integrated into the decision-making loop, not overwhelmed by it or sidelined from it.
Which brings us back, General, to our fundamental definitional question for today. What are key elements for requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation? What does that really look like?
For me, the key elements are fundamentally centered on data resilience and human factors integration. They demand robust physical sensor integration speed, depth, engine metrics, all feeding reliably into certified electronic charting systems. This needs to be supported by highly resilient, probably multiband connectivity, but with built-in cyber segregation and constant integrity checks. And perhaps most critically, the specification must prioritize designs that actively minimize cognitive load on the watchstander.
And I would synthesize that by emphasizing mandatory compliance and standardization as the framework. Yes, the key elements are robust data standards, strict adherence to IMO e-navigation principles across all hardware, but this must be coupled with prescriptive procedural requirements. Things like mandatory advanced training modules tied to specific systems, guaranteed system resilience against known cyber and spoofing threats, and crucially, an ongoing mandated process for assessing and updating the specification itself to keep pace with evolving environmental rules, new vessel types, and emerging technologies. The sheer complexity of trying to unify these specifications for truly global navigation, accounting for the immense variance on vessel types, different operating regions, the rapidly changing rules for green fuels, it just means that perpetual adaptation, constant refinement of these technical requirements is really the only viable path forward. We are specifying systems that need to function flawlessly on everything from, a river barge pushing chemicals to a massive high seas container ship facing typhoons.
But the ultimate goal of that adaptation, Commodore Perry, it really should be to benefit the crew, shouldn't it? Achieving a truly comprehensive and effective global navigation specification requires more than just hardware excellence or faster satellite links. It demands, I think, a fundamental commitment to the digital seafarer, ensuring that the technological demands we place on them actually reduce rather than increase their cognitive burden. That allows the experienced mariner to focus on the bigger picture, overall mission safety, and effective risk management.
Well, this discussion certainly confirms that while technology is advancing maritime navigation at an incredible rate, the governing requirements, the specifications, must be constantly, rigorously evaluated against both technical feasibility and those catastrophic human factors risks that, sadly, historical incidents continue to highlight.
Indeed. The challenge remains finding that right balance between the prescriptive necessity of safety and the required agility to embrace beneficial technology effectively.
Thank you for joining us for this investigation.
Until next time.